Hi students, welcome to Max Point of View. Today we are going to understand the concept of magnifying glass and application of lenses. This is part D of refraction through lens, that is the main chapter. Okay, here we are going to understand the concept. After this we are going to solve each and every theory question. So this is important. After watching this one, go back to that. All the videos of all the chapters are available in the description box. Just go to the description box so that you can jump from one video to any video at any time. So without wasting any time, we'll start with our concept. We need to understand which are the topics are there for the syllabus and which are not. Okay, when it comes to part D of refraction through lens, many students will think the complete part D is only not there in the syllabus. So few topics are there. These are the topics are there, and these are the topics which are not there in the syllabus. Okay, first we need to identify that, then we have to learn it, then it will be easy for us, so that if it is not there in the syllabus, we don't have to focus on that and we can aram se learn the remaining things. Now we are going to talk about magnifying glass. If you know this much about it, then that means you know everything. So magnifying glass, how do you define it? It's a very simple definition. Okay, magnifying glass is a convex lens of shorter focal length. Magnifying glass is a convex lens of shorter focal length which is used to observe the tiny object distinctly. Tiny object distinctly. That tiny objects, why we are using magnifying glass? To observe the tiny object in a enlarged, as an enlarged image, correct? That is the definition. That's it. Next, another name. And one more thing, when it comes to magnifying glass, only convex lens is possible, concave lens is not possible. What is the application of magnifying glass? To see the bigger image. But we know in concave lens, enlarged or magnified image is not possible. The images obtained by a concave lens is always diminished or smaller. That is why we are using only convex lens for magnifying glass. Keep that in mind. Next, another name. So this is very much important because question can be asked in any name, correct? Magnifying glass we know. What if they use another name? That is nothing but simple microscope. Simple microscope means what? Magnifying glass. Keep this in mind. So they can use magnifying glass or simple microscope. They can use any word, so that you have to be ready with both the words. Next, principle. Very simple. If you know the definition, you can write the principle. To observe tiny objects distinctly. That's it. This is the principle. Now we'll talk about distinct vision. Distinct vision is nothing but, okay, you're going to keep any object, newspaper or any object. Okay, assume you are talking about newspaper. If you keep a newspaper here, so if you see a clear image of the letters as well as the picture, that is the distinct vision. So the distance from your eye to the newspaper object, okay, so that is the distinct vision. Now if you bring it too close or too away, again it starts getting blur. So where you are going to get the sharp image of an object, that is the distinct vision. For a normal person, distinct vision is 25 centimeter. And when it comes to distinct vision, you are not supposed to wear any glasses. This is with the naked eye without glasses. Okay, so you understood what is distinct vision, correct? Why this is important, we are going to learn now. Ray diagram. See, I told you in the definition itself, it is only related to convex lens. If it is convex lens, we know all the ray diagram, correct? So which ray diagram we are talking about? What is the definition? It is a convex lens of shorter focal length. That means it is the last case of convex lens. This is the diagram. This is the last case of convex lens, right? So when you keep an object between focal length and the optic center, between focal length of the optic center. So what is the important thing about this ray diagram? When it comes to magnifying glass, you have to remember this image. You have to remember, this is the only possible ray diagram for magnifying glass or simple microscope. So when it comes to simple or magnifying glass, you need to understand this is the only ray diagram. That's it. So when it comes to ray diagram, you know, we have learned how to draw this ray diagram in part B, correct? So if you know this one, we need to know the nature also. So what is the nature? First, where is the object be placed? So all these things are important. Where is the object be placed? Object is placed between focal length and focus and optic center. Where you are getting the image, that is behind the object on the same side. This you have to mention. Okay, on the same side of the object. See, object is here. Okay, on the same side, image will be there, correct? So image is on the same side of the object, behind it. Next up, so these are the position of object and image. What is the nature of the image? Okay, nature is virtual, erect and magnified. So if you know this much about the ray diagram, that is enough. First thing, you need to remember the ray diagram. What is the position of object, what is the position of image, then nature of image. That's it. Next, magnifying power. Now when it comes to magnifying power, see this magnifying power formula, this is the formula. Okay, this is the formula. Based on this formula, no numericals will be asked. Keep that in mind. No numericals will be asked. That is mentioned in the scope of syllabus. Okay, so based on the scope of syllabus only, we are conducting these sessions so that it will be very useful for you guys. Next, listen, magnifying glass. So m is equal to magnifying glass 1, that is a constant. Next, d means many students will think it's a diopter, unit of power. No, completely wrong. That is nothing but distinct vision. That is why we learnt distinct vision. So d is nothing but distinct vision. Most of the cases distinct vision will be mentioned in the question. If it is not mentioned, you have to take it as 25 centimeter. 99% of the time 25 centimeter is the distinct vision. If not, they'll mention in the question. Next, this f is nothing but focal length. How focal length is related to magnifying glass? Okay, if focal length is minimum, magnifying glass will be maximum. So these two are inversely proportional. If you want to increase magnifying power, okay, you have to reduce the focal length. Then only magnifying power will be increased. Most of the time I told you distinct power is constant. Okay, so what is the only main factor about magnifying power? That is focal length. Keep that in mind. Next, uses. So why we are using it and where we are using it. So as I think you understood why we are using microscope, simple microscope or magnifying glass, to see and read the small letters. Next one, watchmakers. So watchmakers will keep an eyepiece, okay, almost like here, okay, like this, okay, to see the small parts and the screws of the watch. That is the one application. Then it is used in optical instruments such as travel microscope. In the exam, we should not use TM. Okay, it means many things. That's why we should not use the short form travel microscope. I don't have space here, that's why I have used travel microscope. Okay, it can be used as a travel microscope. That is nothing but portable microscope. Next, spectrometer. So what do you mean by spectrometer? That's a device used to measure the wavelengths of different spectrum. Spectrum means it's a band of colors or it's a band of electromagnetic radiation. That is what we are going to learn in the next chapter. So for now, you just know spectrometer. It is used in spectrometer. Next, reading lens. So we have learnt it here, right? What do you mean by reading lens? See, this reading is different, this reading is different. This means taking a newspaper and reading it. A reading lens means, you know, vernier scale, vernier caliper, correct? On the vernier scale, okay, on the vernier scale, this small magnifying glass will be kept to note down the readings, to note down the proper readings. In that way, they are telling reading lens. So these are the applications, and this much if you know about magnifying glass, that is enough. Now we'll talk about applications of lenses, where actually we are using it. See, telescope, camera, slide projector, this is what. See, whenever we are learning the ray diagrams, in every ray diagram there was application, correct? There, that one only we are combining it together. That's it. So if you have learned there, that is okay. Now we are combining and learning. Next, they are used in telescope, camera and slide projectors. Then our eye lens is also made up of one of the lenses, that is nothing but convex lens. Our eye lens is nothing but convex lens. Keep that in mind. So for eye lens we have what? Convex lens. So if we are using convex lens, we know what is the main property of convex lens. It produces a real and inverted. Are we seeing the objects inverted? No, right? The lens, convex lens, produces inverted image. Our brain will convert that inverted image into upright image, so that we are, even though it is real, it is not inverted, it is upright. So what lens we have in our eyes? That is convex lens. Then long sightedness. So long sightedness, that means the people who cannot see the nearer objects, but they can see the objects which are far away from them. So that is nothing but long sightedness. So in other way we can call it as hypermetropia. In the exam they can use anything. So long sightedness means they can see the objects which are away from them, too far, okay, but they are not able to see the objects which are near to them. So that is long sightedness. This can be corrected using convex lens. Convex lens. Then it is exactly opposite to short sightedness. That is nothing but, see, long sightedness is nothing but hypermetropia, short sightedness is nothing but myopia. They can use any one of the words. So short sightedness means this is common. So people who can see the objects which are near and they are not able to see or read the letters properly which are away from them. So that is short sightedness or myopia. For this we use concave lens. Okay, after getting older you may get both long sightedness as well as short sightedness. So these are not the diseases, these are the problems we have in our eyes, correct? So as you grow older you may get both. Then we are going to use bifocal lens. What we are going to use? Bifocal lens. That means in the same spectacles you have both the lenses. Okay, you have both the lenses. Upper part, that is concave, below part of the spectacles is convex. Then see, this question that is not there in the syllabus, but we can in the syllabus means it is not there in the textbook, but we can create. So the upper part of the bifocal lens is used to clear the what kind of problem. So concave lens is used to clear short sightedness, correct? So upper part is used to clear the short sightedness, below part is used to clear the long sightedness. That's it. Next, magnifying glass. We know the use of magnifying glass, correct? Next, collimator of a spectroscope. In a spectroscope there will be a collimator, a part will be called as collimator. In that collimator we are using convex lens just to get the parallel beam of light. Why we are using convex lens in collimator? To get the beam of light. This is the function of convex lens in collimator of a spectroscope. Next, Galilean telescope. In Galilean telescope we are using concave lens. We are using concave lens. Why we have to use concave lens? Very simple. To get erect image. To get the erect image. So we are in a Galilean telescope, the image will be inverted. That is the final image. Final image will be inverted. To get the final image as an erect image, we use concave lens in Galilean telescope. Then chromatic aberration. So this one is very much important and it is very simple to understand. Listen, chromatic aberration means whenever you see any object using a microscope, telescope or camera, or we have lens in our eyes, no, wherever we have lens, this problem may occur. Chromatic aberration. So that means some images will be overcolored or blurred. Okay, overcolored or blurred. There, so we are going to get the blurred image or overcolored image, correct? So how to correct it? By using both the lenses. Okay, if we use both the lenses, both concave and convex, so this chromatic aberration will get cleared. So these are the applications of lenses. Now we'll talk about some difference between convex and concave lenses. Listen, how can we differentiate? By touching it. Okay, by touching it, if middle part, okay, middle part is thick and edge is thin, then it is convex lens. Exact opposite, middle part is thin. See, this edge is also called as periphery. Okay, this is what we learned in part A. Edge is nothing but periphery. We can use the word periphery also. Middle thin, edge thick, then it is concave. If you can imagine the diagram, okay, just of the lens, the image of the lens, how, see, convex lens, see, the middle part is thick, correct, middle part is thick compared to the edge, so this is convex. Then see here, the edge, compare the edge with the middle part, edge is thicker than the middle part, so it is concave. That's it. Next, by seeing the image, there are two types. You can use any one to identify the type of lens. So listen, size. So when it comes to image, if the size is magnified, okay, if the size magnified, we are not talking about the object, we are talking about the image, that is important. If the size is magnified, that means it is convex lens. Diminished, it is concave lens. So what do you mean by this one? Very simple. Magnified, we know when it comes to concave lens, there is no possibility to get a magnified image. Whatever the image we are going to get from concave lens, it is always diminished. This condition we know. This is what we have learned in part B ray diagram, correct? So concave lens, there is no magnified image. Size of the image, if the size is increased, that is obviously always convex. Okay, if the size is diminished, that is also possible in both the lenses, but if for a particular image, for a particular object, assume you are taking a newspaper and use a convex lens. If you go close, if you keep on changing the position of lens, you can see at some point you can see magnified image, correct? That is convex. If you take the concave lens, but if you keep at any distance, the image is always diminished, size of the letters are always small, that means it is concave lens. This is how we can identify. Next, nature. So if the image is inverted, see, whether it is real or virtual we cannot identify. Only while drawing the ray diagram we can say by intersection. If you see the intersection of refracted rays, that means it is real. How can we see it? We cannot see the refracted rays only. We can see only the image, correct? So only for drawing the ray diagram we can say whether it is real or virtual. But in actual case, see, I am looking at many objects here, but here we cannot say whether it is real or virtual. But if the image is inverted, then it is convex lens. If it is erect or upright, it will be concave lens. That's it. So using the basics, we can aramse differentiate between both the lenses. So for now, we have completely learned the topic of part B, that is magnifying glass and application of lenses. So many things are not there in the syllabus, so don't worry about it. So what we have learned in the video, that is enough. Thank you.